In this video we're going to look at finding the equations of straight lines. There are several different situations we might find ourselves in, and there's a couple of different strategies we can use. A straight line can be found using the equation y equals mx plus c, where m is your gradient, the steepness of your slope, and c is your y-intercept, where your graph crosses the y-axis. You can also use this second formula, y minus b equals mx minus a. And this is used when you know m, the gradient, and when AB is just a point on the line. So this is useful when you do not know the y-intercept. So this would be if you were in a position like this. Here are three problems. So we're going to find the equation first of the line with gradient of 2 passing through the point 0, minus 3. So I have got the gradient is 2. Carefully studying this point, I can see 0, minus 3 is actually a point on the y-axis. I would go along 0 down to minus 3. So this is telling me my y-intercept, c, is equal to negative 3. I can go y equals mx plus c, so my equation of my line is just y equals 2x add minus 3. So minus 3 at the end there. B, I have been told the gradient is minus 3. And I've been told it is passing through the point 0, 2. So again, I've got a point on the y-axis, along 0, up 2. So this will allow me to use y equals mx plus c. I know my y-intercept, c, is positive 2. So y equals mx plus c will be y equals negative 3x plus 2. Question C. Again, I have been told I have got a gradient of 1/2. Minus 3, 2 is not on the y-axis, so we cannot jump straight to our answer like before. We have got a point AB is minus 3, 2. Now there are two ways of tackling this. You can use this equation. So we're using the second straight line equation here. I can substitute in my gradient, m is 1/2, and I can substitute in the values for a and b. So I have got y minus 2 equals 1/2 x minus negative 3. So all I have done there is I have substituted in a and b for the x and y coordinates of the point I know. I now need to multiply this out and tidy it up. So y minus 2 isn't going to change. I've got 1/2 times x, the negative of negative 3, so minusing negative 3, this is all going to be plus 3. So 1/2 of plus 3, I could say 1.5, or I could have 3 over 2 there. I'm going to add 2 onto each side, and that will give me y equals 1/2 x plus 3.5. Or There is an alternative way we can do this. We can actually use y equals mx plus c. I know my gradient is a half, but I don't know my y-intercept. To find my y-intercept, I could swap in the coordinate I know for x and y. So I could think of my point xy equals minus 3, 2. So I could swap a y for 2, equals a half of x I can swap for negative 3 plus c. And I can work my way through this. 2 equals a half of negative 3. Well, that's negative 1.5 plus c. I can add 1.5 to each side, and that will give me the plus c on its own. 3.5 equals c. So this tells me my equation will be y equals a half x, because we already know the gradient, and we have just figured out the y-intercept, plus 3.5. It's entirely up to you which of these two methods you use. Using this is a little bit quicker, but it gives you another rule to memorise. Using this takes longer, but it just relies on the rule we should know already. For the remainder of this video, I'm just going to use this method when I don't know my y-intercept. That said, this is still perfectly appropriate if you want to use it. 2 more questions. Find the equation of the line passing through the points 0, 1 and 1, 3. So this is different from the one before. We have not been told our gradient. We have to figure out the gradient for ourselves. The gradient can be found. The difference in your y coordinates divided by the difference in your x coordinates. This is because the gradient is defined as the vertical distance divided by your horizontal. So the difference in your y's is looking at the difference in your vertical distances. The difference in the x's is looking at a horizontal distance. I always write my points down, or if I've got them written down up here, I always label them. So x coordinates come first, so I'll say that's x1 and that's x2. Y coordinates are always the second one, so I'll call that y1 and y2. By doing that, I know exactly what numbers I'm going to put into my formula and where I'm going to put them. y2 minus y1. 3 minus 1 over x2 minus x1. 1 minus nothing. That'll tell me my gradient is 2 over 1, which is just 2. Taking a second and looking at both of the points we've got, we can see that this one, 0, 1, is a point along 0, up 1. It is a point on the y-axis. So this means I know my y-intercept. My y-intercept is 1. This allows me to put my equation together really quickly. Y equals mx plus c. My gradient is 2. My y-intercept is 1. 2x plus 1. B. I'm in the same situation here. I don't know what my gradient is, so I'm going to have to calculate it. So the gradient is the difference in my y's over the difference in my x's. I've got my coordinates written down, So I'm going to label them. First one's my x, x1, x2. The second one's the y's, y1, y2. I'm going to substitute these values in. I'm going to need to take care with these three negatives. So I've got negative 10 minus 0, and I've got negative 2 minus negative 4. So my gradient, negative 10 minus 0 will give me negative 10 on the top. Negative 2 minus negative 4, well, this is the same as adding positive 4 here. So minus 2 add positive 4 will take me to positive 2. Negative 10 divided by 2 gives me a gradient of negative 5. I need to choose how I'm going to find my equation. You might be tempted to say the y-intercept is negative 4, but if we take a second to think about what that coordinate looks like, it is back 4 up 0. So it's a root, or an x-intercept if we want. So we don't know what our y-intercept is. So we could use y minus b equals mx minus a. Substitute in one of my points. I would probably substitute in this one, just because substituting in a 0 can be useful. So I'm going to call this a, b now, so I'm giving it an extra label. Y minus 0 equals negative 5, x minus negative 4. That'll give me y equals negative 5, x plus 4. Just taking a little second to tidy up that minus negative, just so I don't get muddled when I multiply by that negative 5 there. So y is negative 5x minus 20. I would have got the same result if I substituted in this. I'd have just had to do a little bit more number work. I'd also get exactly the same result if I used y equals mx plus c and used the procedure I used on the third question on the previous page. These questions here look identical to the ones on the previous page, but taking a second to actually study the coordinates will show it's not. In this first pair here, I have got the same number twice. Remember, coordinates are always described as an x coordinate and a y coordinate. By inspecting the coordinates in question A, I can see y is equal to 1. If I was to draw that, that would look like a horizontal line passing through 1 on the y-axis. Same thing's happening in the second one. If we have a look, the x coordinates are the same. So in B, the x coordinate is always minus 7. If I were to sketch that, it would look a little bit like this. A vertical line passing through minus 7 on the x-axis. If you were to try and calculate the gradient of this, you would end up with 4 over 0, because the difference in your y's is nothing. If you try and divide anything by nothing, you will get an undefined value. A infinite slope up and down the way, one which we cannot measure the steepness of, is said to have an undefined gradient. Question C. Same as before, we can see both of the y coordinates are 0. So we can say for C, y equals 0. Last but not least, we've got these two questions here. Find the equation of the line parallel to y equals 3x minus 5 passing through 0, 7. We have not been implicitly told what the gradient is. However, we should know if lines are parallel, their gradients are equal. Y equals 3x minus 5. The coefficient of x is 3. So the gradient is going to be 3. I have got the point 0, 7. 0, 7 is a long 0 up 7. So I have got a y-intercept. This means I can just go ahead and write down my equation. Y equals mx plus c. Y equals 3x plus 7. The next one. Well, the wording is exactly the same as part A. There's a little bit more work involved. We're looking for the equation of a line parallel to x plus 2y equals 3. You might be tempted to say the gradient will be 1. However, this equation is not in the y equals mx plus c format. We will need to make y the subject before we can pull the gradient out. Also, we don't have a y-intercept. We've got a random point on the line. So first things first, I'm going to make y the subject to find my gradient. So I'm going to start by subtracting an x from each side. So x minus x will give me nothing. Will leave me with 2y on the left. And I'll have 3 minus x on the right. I need y to be the subject, 1y. So I divide everything by 2. So y equals 3 over 2 minus a half of x. Or I could write that as x over 2. I think writing it like this, though, makes it really clear what the gradient is. The coefficient of x is negative 1/2. So my gradient is negative 1 over 2. I've got a point on the line. AB is 2 minus 1. So I can use one of two methods. I can go y minus b equals mx minus a. Y minus b. B is negative 1. Equals negative 1/2 x minus a. So a is 2. I'm going to tidy this up on the left. This bracket on the right doesn't require tidying up, so I can multiply out just now. Equals negative 1/2 x, negative 1/2 of negative 2. Well, that's going to be positive. Half of 2, 1. If I minus 1 from each side, I'm going to get y on its own equals negative 1/2 x plus nothing. So if I were to sketch this, it's got an intercept on the y-axis of nothing. Negative 1/2 means it'd be going downhill like that. And of course there's always the alternative strategy for this one here, using y equals mx plus c and substituting your point in for m and x, and that will give you exactly the same result.